I'm Jessica Putman, the student coordinator for the Roxborough Roundtables. Today is our final installment for the semester of the Roundtables, and the topic is the material science and sustainability, because things are made out of stuff. Our host today will be Dean Ronald Kander.
Thank you very much. So today's topic, as you heard, is things are made out of stuff. We want to talk about the material science and sustainability. So I'm Ron Kander. I'm the executive dean for Kanbar College here at Philadelphia University. We wanted to start by going around the table real quick and let folks introduce who they are and where they are associated with the university. So we'll start with you, Tom, and then we'll get to the topic.
Thank you, Ron. This is Tom Fong. I'm part of the graduate program in Global Fashion Enterprise.
I'm Kyle Thorpe. I am part of the industrial design major here at Philadelphia University.
My name is Brittany Ray Buckmeyer, and I am a senior fashion industry management student.
Good afternoon, everybody. This is George Kennedy. I'm an instructor in the night course for environmental science. Thank you.
Hello, my name is Matt Gindelsberger. I'm a visiting assistant professor in architecture at CABE, and I focus in building systems and technology.
I'm Tom Strand. I'm the program director for our major in environmental sustainability.
I'm Nathan Polinkus. I'm a sophomore student here at PhilU, studying accounting currently.
This is Derek Scamenti. I am a senior graphic designer.
Thank you all. We have a great eclectic group to talk about this subject today. So what I'm going to do is spend the first 5 minutes or so and kind of set up the problem that I want to talk about with all of you. And let me start by talking about the evolution of materials in our society, because I think that's where we need to start. So you've all seen like the evolution of dance, the YouTube video. So this is sort of like that, but I don't dance, so I'm just going to do it in words. Thank God. Yeah. So if you go back to 50 BC, sorry to have to go back that far, but if you go to 50 BC, there were about 5 or 10 materials that were of any engineering significance that were used by mankind to make things. Things like wood, leather, stone, bronze, silver, the basic materials that were available back then. If we fast forward about 2,000 years to about 1900, that number of 10 to 20 is now about 100 to 200. So in 2,000 years, it only went up by 1 order of magnitude. So we're still only talking about a couple hundred materials that we could use to make things from. Okay? Now, if you go from 1900 to today, which is only a little over 100 years, that number of 100 to 200 materials has gone to between 100,000 and 200,000. So we've gone up by 3 orders of magnitude in about 100 years. And actually less than 100 years, because it really was about the 1940s when this thing started. So we've reached this age of what we call advanced materials. So it's fundamentally changed the way we make things, the way we use things, and the way we dispose of things. And that's what I want to start with today. And the example I brought today that I think brings the idea home is the telephone. In addition to kind of having all these materials available, if you look at the periodic table of elements, right, you all saw that in school, about a third of those elements on the periodic table are now identified by the U.S. government as what they call critical materials. That means either there's very little of it available to the world, or it's so toxic or dangerous to people that we have to limit its use, or it's located somewhere geopolitically in the world where we can't get to it in a reliable way. So they're critical materials in the sense you don't want to design things using those materials if you can help it, because your design may be limited by the loss of those things someday, either by legislation or by war or whatever. So if you keep that in mind, a third of the periodic table. So let's go to the telephone. I'm showing the audience here a picture of the phone that, unfortunately, I have to say, for the faculty in the room, we had as kids. For the students in the room, your parents or grandparents had as kids. But the old black Bell telephone phone that had the rotary dial on it, right? Compare that to today's cell phones, okay? That old phone weighed about 5 pounds. Today's phone weighs about 4 ounces, about a quarter of a pound. So from a sustainability point of view, the first rule of sustainability we all know is reduce, right? Reduce the amount of materials. So on the surface, sounds pretty good, right? We've gone from a 5-pound device to a 3 or 4 ounce device. That's going in the right direction, apparently. But you have to layer on top of that the fact that at the peak of manufacture of those old phones, we were making about 10 million a year. The peak of production of today's smartphones is about 1 billion a year. 100 times as many a year of these things, which completely wipes out that materials advantage that we just talked about, right? And why do we make so many? That old black phone lasted more than 10 years, way more than 10 years. These, average lifetime, under 2 years, are cell phones. So if you layer those two pieces of information, you completely blow out that weight thing, and it's a completely unsustainable situation. We have these cell phones that we're burning through material at a rate that's orders of magnitudes bigger than we ever did for our communications. Now, remember I mentioned those critical materials. 2 interesting facts you can take home and impress your friends with. That cell phone in your pocket contains half of the periodic table. Half of the periodic table is somewhere in your phone. And what's worse yet, 60% of the critical material list is in your phone. You got lithium, barium, cobalt, gallium, germanium, barium, palladium. You have all these elements that are nasty or in limited supply.
All heavy metals.
All heavy metals, and you're burning through them at 1 billion phones a year and throwing them away every 2 years. Okay? So therein lies the issue. So we're in this age of critical material resource management somehow. And one of the points I want to talk about with you all is the problem is now that we have hundreds of thousands of materials available to us, and we're running into this problem that I just described, understanding and appreciating the life cycle sustainability problem of any product anymore involves you to have such an intimate understanding of the material science behind the materials that are going into that thing, that how do lay people make intelligent decisions about what they should or shouldn't buy or use, and how do you get enough information to them in a way that they can process it and use it? It's such a complex systems problem now compared to what it was when there were 100 materials to choose from and everybody could be an expert on the things that things were made out of, right? This is the things are made out of stuff problem. That's the title of the issue. So before we get any deeper into this, I just want to hear a few thoughts from you guys about A, your understanding of the level of that problem, and B, your initial thoughts about what we do about it as a society.
You mentioned
Names so that people know.
This is George Kennedy speaking. You mentioned a 2-year cycle. Is there anyone here around the table that recycles their phone on a more accelerated basis where they don't even wait 2 years?
Oh, yeah, sure.
So I'm thinking if you're talking about the production in terms of the volume of the units being so much more and like that, so I'm thinking it's even faster than we think it is.
Oh, yeah.
My last cell phone.
Names for the mic.
All right, I'm Nate. My last cell phone that I used, I used it for 4.5 years. It was a small, regular one. It wasn't really a smartphone, just a regular old basic plan cell phone. Still managed to keep it, usable until it finally just broke.
Mm-hmm. And then now, though, what do you have?
I also have another kind of that same phone. Another one I just throw in the trash. There's really not any cell phone recycle places that are available to me in my area.
Yeah. Tom?
Yeah, this is Tom Fong. I want to piggyback on Nate's comment on, you mentioned about heavy metal, but if I could just kind of piggyback on that, I think it's classified as rare earth metals because they're so rare. Ron, correct me if I'm wrong, I think in the United States we have a pretty good reserve, and then of course over the last 10-15 years, China now has the bulk of this stuff in our country. So getting back into George, this is more of a geopolitical challenge as well as a sustainable, reusable challenge, And then of course on top of that is the whole notion that consumer behavior is part of this gig. I mean, I think there's a joke going around is if you are holding a cell phone more than 2 years old, you are then a certain age bracket, which is like me.
Yeah, my name's Brittany, and I just wanted to say that I am in my business capstone class right now, and it's focused on corporate social responsibility. And in today's class, our professor Jason Crook brought up a great point that it's not only the responsibility of businesses to close the loop, but it's also the responsibility of the end user. And Nate?
Yes.
Yeah, what Nate said earlier about, I don't have a recycling program near me, or like maybe it's not that you don't have it, maybe it's that you need to seek it out. Maybe as consumers we need to be a bit more responsible and take ownership of that and our role in the whole thing. We can't just blame, Apple keeps like printing out these phones. It's like, well, if you're still buying them and if you're not recycling them properly, that you're contributing to the issue as well. You can't just pin it on a scapegoat company.
This is Ron again, but to follow up on what you said, Brittany, so everything we learn and we teach about in the DEC core curriculum about finding pain points and looking for value propositions and opportunities. So we could also turn this around and say, okay, that means there's a business opportunity here, right? And I think you're starting to see this happening, right? That there are businesses specifically designed around filling that gap between where the consumer behavior ends and where companies pick up. And there's that, if there were ways for you to very easily recycle products like this and get them back into a usable form or a reuse or at least recover the metals, then there may be some real value there that could be added right to the cycle. So maybe there's business opportunity.
George back in, working on the recyclable end, one thing I started out doing was just going to free websites. Who doesn't like anything for free? I recycle. And they can identify tons of like local recycling centers where you don't even have to have purchased the item at that, and you can quickly go in and they'll take it, no questions asked. And it's starting that chain where you're trying to recycle to get some of those more precious materials back into the production cycle when you go that way. And you can go to any of your like big box kind of stores like Best Buy and stuff like that, and they just love to have that. And just recently I got a new phone. I got out of that 2-year cycle right that, and I found out that you can get a lot of money for your old phone. Doesn't even have to be in great working condition. So if you can just give to the phone guy, just give him your old phone back, and you can get money, which is going to defray some of your purchase for a new phone. But you're getting the materials recycled in the most responsible and sustainable way.
So this is Tom Schramm. I don't know if I'm jumping ahead, maybe we're going to get to this later in the session, but we're going to talk about the cradle-to-cradle idea, where the manufacturer of a product becomes responsible for taking it back at the end of its life cycle.
Yeah, for the audience, cradle-to-cradle is this concept that the manufacturer is ultimately responsible for the recycle of the product. A good example is automakers in Germany. Or Mercedes. If you buy a Mercedes in Germany, when you're done with it, you can bring it right back to the Mercedes place. It's their responsibility to disassemble it, do something with the parts, either reuse them, recycle them, do whatever. And that has to be built into their business model by law, by federal law. That's a really good point, because now we're getting to the politics of the issue. Because you can imagine how that would work in a country in Europe. It's very hard to imagine how that would work in the United States. I'm not saying we can't do it, but we would have to come up with an incentivized model of some sort that makes it worth a company in the United States to do it. And the second thing I'd like you to comment on, Tom, to that is also, as you get to global supply chains, it becomes really difficult to determine whether the true life cycle value of recycling is there. Because there are products, talk about the 3 R's, reduce, reuse, recycle. I like to talk about the 5 R's, because it's really reduce, reuse, recycle, recover, remove. Recover meaning recover the energy by incineration, which many times is the most responsible thing to do. And remove is landfill. Remove it from the cycle and put it in the landfill. And sometimes that's the best thing to do. It actually takes more energy and creates more CO2 emission to recycle something sometimes than it does to get rid of it. And how do you do that complex calculation and come up with legislation that is consistent?
Well, I think part of the genius of the cradle-to-cradle model, if you can make it work, and let's use cell phones, and we can use Apple as an example. If the Apple company knew that at the end of the life cycle they're going to take your iPhone and they're now holding it, they got the hot potato and it's full of heavy metals and also valuable materials. They're going to approach at the beginning, before they make that phone, they're going to think very differently. How do we design this up front so that when it gets back to us, it's easily disassembled and the materials can be recycled, recaptured, and used in a profitable way. So once they sell it, the consumer's just going to throw it away and Apple doesn't have to worry about it. They'll design it one way and they'll do the cheapest, most efficient way from that mindset. But if they know it's going to come back to them and they're going to be left holding the bag, they're going to think differently at the beginning of the design process. And that's what kind of changes the equation for them.
Yeah, this is Tom Fong. I was in Germany going back maybe 15 years ago to see a trade show in Düsseldorf, which is the biggest packaging show in the world. It's every 3 years. It's called Interpack. And I left Philadelphia and took a flight to Frankfurt. So the first thing I do is I got to get some cash. So I was looking for receipts from the ATM machine, and the gentleman behind me spoke in perfect English. He's German. He said, "Well, sir, we don't give out receipts at the ATM machines." And that was a big, big thing to me. And the point I'm making is like, it seems to me it's more of a mindset. You could say that it's a cultural thing, now whether it gets involved with politics, and I think we could talk about that a little later. The point I want to make is that, piggyback on Ron, your 5 hours, I could say that I came from an era of linear economy because, I went to school as a chemical engineer. I spent my entire professional career in the consumer packaged goods industry on the supply chain side of the business. At that time, we just basically like a one-way street. We take raw materials in, we make a finished product. That's the first stage of value capture. We get it to a point that we can sell it to a customer, then we finally capture the value. So the whole cycle is complete. I go home and be happy.
Yeah.
But I think now we live in a world, perhaps it's a whole notion of circular economy, and those 5 hours that you talk about really resonate with that.
And I think, I'm sorry.
Just Brittany, I just wanted to touch on kind of what all three of you guys have been saying about kind of the cultural aspect that can't be ignored here. I just came back from studying abroad in London for 6 months, and it was so interesting in shopping there and being a consumer there, but having an American consumption appetite, if that makes sense.
Yeah.
And just not only in the way that how we're saying, the design, the perspective that we approach design is different, but even just going to the grocery store, they just there's so much more thought about what happens after, and I feel like in America we don't always think that way. We're always like in the now. What do we want now? What are going to satisfy our needs right here? Whereas maybe in some other cultures, maybe we don't print receipts because you're going to look at it and say, okay, crumple it up and throw it away. And maybe that's something as a culture we can try to work to change to address these materials issues.
Mm-hmm. So let's keep going. So we're hitting sort of two parallel paths here. That's what's cool about these discussions. You don't know where they're going to go. I love it. So part of this is we're trying to make the argument that we don't have enough understanding of the true life cycle and its impact as consumers to make informed decisions, right? And the second piece we're hearing is about how can you, by cultural or political means, alter behavior, even if a person then doesn't understand why they should be doing it. Are we making the argument that somebody else is going to decide for them whether it's the right thing to do or not? So I'm sitting in, Uzbekistan somewhere, and I have a cell phone. I may not be thinking about getting it back to Apple, whether Apple is required to recycle or not, or if I'm in a very low income area of the United States and I'm worried about getting enough food to make it through the week with my family, recycling is probably not the highest thing on my mind. So is it our collective responsibility to require that of every citizen, whether it's the highest priority in their mind, or is our job to educate them to the point that they're going to make a decision about the best thing for them to do as individuals? Because we have this, a tragedy of the commons problem, right? If everybody does what's best for them as an individual, that isn't necessarily the best thing for society. At what point are we allowed to say your behavior can't be what you want it to be? It has to be what we say it needs to be.
Evan Lane, you have to add also the political context. If you have the government saying it's best for us actually putting regulations, you're going to have blowback. In the U.S., the nanny state. We have a unique, and you were touching on it, Brittany, mentality here, in the Wild West, where individualists don't tell us what to do, even if it's something absolutely good for us in the world, and we respond because you're telling us what to do, we do the opposite. It's sort of like a child would disobey its parents. And that's something you have to consider, this unique cultural thing that Brittany was talking about. How do we handle that here?
And I'm not convinced that we have government officials at this point that have enough technical knowledge to know how to make informed decisions about what the best decision is anyway. The next example I was going to bring up was something pretty simple and straightforward, sounds like. You get to the end of the grocery line, paper or plastic? What's the right decision? Right? We have legislation in California right now that's saying they're going to outlaw plastic bags from the entire state. Every life cycle assessment analysis I or anybody else has done says that a plastic bag in its life cycle is a more efficient solution than a paper bag in a grocery store. Now, bring your own cloth bag is obviously better than all of those. But if you do have the choice between paper and plastic, the right answer is plastic from a total energy and total CO2 emissions in life cycle. Because, back to the 5 R's, you can very cleanly recover 80 or 85% of the energy from a polyethylene bag by incineration. And it's clean, it's not other plastics that have, carcinogens and other things. Polyethylene's the cleanest, it's the best fuel you can find. It's better than wood, right? And so completely recycling a plastic bag, getting a policy in place that completely recycled the polyethylene bag would give you a much lower life cycle energy cost and CO2 emission cost than paper. Paper's like the worst thing in the world to make. So why did we decide to outlaw plastic? Tom?
This is Tom from. I love it, Ron, because I would say that science not going to win in that day because public opinion, perception, often just trump over that, which is unfortunate because another thing about it in New Jersey, we get rid of all the traffic circles, right? In reality, actually save more fuel when you go to a traffic circle that comes to a full stop. Now, case in point, we all know this, that UPS, they always advise the drivers to make a right turn against a red light, right? Of course, with caution, obviously. So that, they're saying that they save over $1 billion worth of fuel, So sometimes, I guess I get into that same trap here, that it's sometimes intuition might not be the right answer, You just have to sort of get down into it. And I think part of that is to sort of have the whole notion of education. I know sometimes science is not going to win today, but we cannot give up on educating the masses.
Mm-hmm. And this, we're going, this is Ron again, we're going a little bit off topic, but why is it that, and so one of the root problems here is why is it that science and math education on these kind of topics is not considered as socially acceptable or required as other types of education? If you walked into a party and you said, I can't read, right? That would not be a socially acceptable thing to say, right?
No.
You would be actually shunned for saying you're illiterate. But how many times do people at a party say, oh, math, I can't do math, that's stupid, I don't know how to do math, I never liked math, right? And everybody giggles and everybody laughs. It's okay to say, I don't know how to do math, but it's not okay to say I don't know how to read, right? So why is it that being illiterate is acceptable, but being illiterate isn't? And that's sort of at the root of this, not understanding the scientific basis of some of these decisions to make a complex systems decision.
But, well, this is Tom Schramm, but I'm not sure that this is a math or science problem. If you look at the plastic bag situation, we don't have a system that closes the loop to turn plastic bags into fuel right now. I have no idea. Where do I take my plastic bag to have someone burn it for electricity? I have no idea. There's no one collecting that. There's
When you collect them at the grocery store, that's what they're doing. They're taking them to an incineration plant, and they're incinerating them and generating energy.
Okay. So, but...
Yeah.
Nobody knows that, first
Right.
of all. And second of all, I'm director of a sustainability program. I don't know that. so there's a disconnect with the public there. But there's no system for collecting it. So I've got to save them. I've got to drive to the grocery store,
Right.
I've got to turn them over, and then trust that they're going to do something smart with them. It's unlikely behavior.
Okay.
Like this is Nathan again. Like when you see when you're given the choice between paper or plastic, like most people say like, oh, because the bag is like this paper bag is just paper. Like if you just leave that sit outside or something, because I know like a lot of people just dispose of it like just in trash cans or something, that'll break down in a landfill rather easily because it's just paper, it's just wood product. If you get that wet, it's going to go into the dirt, break up, and it's going to go back into the dirt. While you see like plastic bags from like 10, maybe even 10 years still floating around on the highway. So people think, oh, if you leave the plastic bag in a landfill, it just stays there and nothing ever happens to it.
Yeah.
And that's where their perception of whether these products, these materials are more sustainable or more efficient for
Let me address that too, because so have you ever dug to the bottom of a landfill?
I have never been to a landfill.
This is why you're all in college, because people who don't go to college end up having to do those kind of jobs.
That's not true.
Oh no, I'm just joking. Sorry. You do edit these right now. The reality is that most paper gets thrown away in landfills. Landfills are anaerobic, meaning they lack oxygen. So if you go to the bottom of a landfill and pull out a newspaper from 100 years ago, you can read it. It's not going to have degraded because it's not composting. You're not putting oxygen there. So the top layer of a landfill might compost, but the vast majority of a landfill, if you grab that hamburger from the bottom of a landfill, it's probably going to be about like the ones we get over in.
Don't say that about chicken things.
So that's a great example again of where the science enters in the decision, right? If you have a public perception that because a piece of paper on the street composts, that when I throw away a piece of paper it's going to compost, is actually a misconception of understanding the basic physics of what happens.
It's also missing the problem, and this is Matt Gimmelsberger, is the problem that the bag doesn't degrade on its own, or is it a systematic problem that the bag is floating around in the ocean in the first place, or sitting in the gutter of the street in the first place, and that goes back again to the mechanism.
Right.
You can drive down the street and see bags flying out of cars,
and
cigarette butts, whatever, and that's a conscious decision that people make.
Yeah.
Whether they believe it's conscious or not, but it's something people do.
Mm-hmm.
It's despicable.
Yeah. Another classic example, this is Ron again, another classic example that I'll throw out to keep the conversation going of this exact problem of public perception versus the reality of the science is when McDonald's went from the styrofoam clamshells to paper, for wax-coated paper, for wrapping their hamburgers, right?
Yeah.
Why did they do that? Because people don't like to see a clamshell on the side of the road. But actually, if you look at the life cycle recycling of paper versus clamshells, the volume of material in a clamshell is so small that the embedded energy and the total CO2 emissions of that thing is way less than that piece of paper was. And the public feels better about the fact that they forced the decision to go to paper wrap because somehow it seems more sustainable, in air quotes, but it's not. I mean, a styrofoam clamshell is a much more sustainable solution, but nobody will believe that.
Is it a much more sustainable? Is it a much more sustainable solution, assuming a system that appropriately we're dealing with high-tech manufacturing that deals with the energy inputs and outputs appropriately,
exactly,
off gases appropriately, and assumes an optimum condition. That wasn't the case probably not very long ago.
But the point is, if you're going to then spend energy, if you're going to spend time changing the policy, and you know that's the correct end game, why wouldn't you spend the time changing the system to be the most efficient styrofoam clamshell system possible versus jettisoning it and going to a paper bag? It reminds me of, the joke where you see somebody crawling on the ground under a streetlight and you say, "What's wrong?" You say, "I'm looking for my wallet." And you help them and you can't find the wallet. And you say, "Well, where'd you lose it?" And they say, "Back in that alley." You say, "Well, why are you looking out here?" And they say, "Well, the light's better out here." So why don't we look where the light's better rather than where the actual problem solution lies?
Yeah, I think that this is pretty interesting. I'm coming from a fashion perspective, and immediately the first thing I thought about, this science versus public perception is the use of organic cotton. People see organic cotton and they're like, oh my gosh, it's so much more sustainable, when that's not true. That's not necessarily true, and you have to just ask more questions, like, well, what's the dye like? What's the transportation like? Because if you're using organic dye, if you're using an organic fiber, but you're using dyes that are harmful or that pollute waterways, and then you're transporting it with all this fuel, you have to ask bigger questions. And I think we're in this, we believe things really easily. We see something on the internet. How many times have you read an article, a headline on Facebook, and you're like, oh my god, and then you realize it's from The Onion, and you're like, wait, but it sounds it sounds good, and it sounds true, and you believe it, but we have to ask more questions, which is going back, everything we're saying is connecting really nicely, but the whole culture behind the way we buy things and behind the way things are made, that needs to start shifting, because we can't just throw these buzzwords or, consumers today like this better than that, so we'll do that even though it might not work.
So Ron, you were talking about.
The name?
My name's Kyle. Ron, you were talking about in the beginning how there were only 5 materials back in 50 BC, and now there's 200,000 now. And I think, back then those 5 materials were found in the earth. They're all natural, right? And I think we've slowly gone away from the natural materials and started to create our own materials and created unsustainable things. And I think now we're almost hitting a tipping point where we're finding ways to bring the natural back into our society and changing what we've been creating, which is unsustainable, and going back to 50 BC where everything that there was natural.
Okay, so natural materials are safer than man-made materials, huh?
Yeah.
So arsenic and lithium, those are all safe things, right? So they're natural.
Well, bioplastics and PLA. Things
Like Nathan here again, what you were about to say, but now we're also realizing that just because it's natural doesn't mean it's safe, and just because it's man-made, that doesn't mean it's really bad.
Yeah.
We can use ingenuity to make really sustainable plastics. A very simple plastic is just made out of just carbon, just hydrocarbons.
Yeah, right.
And stuff.
Safe material.
And that's fairly safe. There's carbon and hydrogen aren't critical materials. Whereas you can find just arsenic, other heavy metal rare earth metals and stuff in rocks. And that's where they're from.
Yeah.
Well, they're starting to make clothes using tea, sugar, and microbes, and we're becoming such a complex society where we are able to create things that are good for the world, and that don't trash it.
And there is one thing that a long time ago, back to the ancient Romans and stuff, there's one material that they used for everything, and they still used for a very long time up until very recently: asbestos. Asbestos was used in ancient Roman shields, ancient Roman housing,
And lead.
Lead too. Yeah, they put lead on their food because they could make lead acetate, which they'd leave lead in the bottom of their wine barrels, and would taste sweet, and it would eventually rot their brains and kill them because lead's bad for you.
But it was natural.
It was very natural.
And that might not have been the first thing that killed you.
You go mad first. I think this is Tom from here. Talking about lead, this is something that's close to my career. I spent 30 years making tin cans. I worked for a company called Campbell Soup Company, and that's how tin can was made at one point in time. And if you go back in time, that whole food preservation saved a lot of lives still in World War I, because famine was a bad thing. So people didn't know back then, the tin can afforded human exploration, the North Pole, South Pole. Those are all basically, food, a way to preserve food. So lead is not necessarily that bad. It just makes you crazy.
That's okay.
So to keep this rolling, I'm gonna throw one more example out and get you guys to comment on it. So I think that'll fill up our time here. So let's fast forward then to a bigger example, and let's talk about transportation and electric cars. Okay, so one of the things in the news recently is Tesla. Tesla wants to build the mega plant to make batteries out in New Mexico or somewhere out in the
Yeah.
Midwest or in the West, far West. And they, the proposal there is to build this mega plant to make lithium-ion batteries for automotive transportation. And the point is, if we could eliminate gasoline emissions, go to electric cars, huge benefit for greenhouse gases, etc. So let's think about that from the point of view of the total life cycle of a vehicle. How sustainable are lithium-ion batteries, and the life cycle of lithium-ion battery compared to the emissions associated with gasoline or other petroleum fuels, especially when you put in a dear friend of mine, Michael Ashby, who's at Oxford in England. I was over there last year and was with him, and he did a great calculation, and he said, let's assume that all the vehicles in the world were replaced by electric cars. There's not enough lithium in the world to make the batteries that you'd need to run the cars. So long before you ever got to a point of electric vehicles as the primary vehicle transportation mechanism, you would have jacked the price of lithium up so much as you started to run out of it. So how do you get something as complex as the life cycle of materials in cars linked into this thing of just fuel efficiency and what's the best sustainable solution for vehicles?
I think there's something interesting about
This is Matt.
This is Matt. Sorry. That idea of just calculating how much lithium there is. Can we also calculate how much available petroleum there is, that we could do the same sort of calculation.
Exactly.
Which one do we run out of first?
Mm-hmm.
And I don't think the silver bullet is either one of those, but a portion of that silver bullet really takes a look at the entire infrastructure of the vehicle itself, making the whole vehicle lighter weight, thinking about composite structures for the frame and assembly so that we're reducing metals, things like that. So if a car can weigh half as much and be twice as safe, what's the lithium number look like then? What's the gas number look like then?
Mm-hmm.
I don't know. It's a little bit difficult to engage into that sort of a question from a singular fuel source perspective, because of all of the other compounded variables that are a part of that.
This is Tom Fong. I think this is a great topic because, we're really focusing on the whole notion of mobility. Especially we Americans, we want to drive. Forget about buses. But I believe that is perhaps one of the many solutions. If I could just, talk about nuclear, okay? Is one of the solutions. I believe, and you might say that I'm a utopia world. The hydrogen economy was a topic that popped up maybe about 20, 30 years ago. So I'm still kind of keen on the combustion engine. It's been around 300 years. It's still working pretty well. The whole thing about is how to feed that baby.
Yep.
So if you have something that is like abundance, hydrogen, we don't know how to make that without using less energy going in. I think guys working on plasma physics are working on that right now.
Or solar to make hydrogen.
Yeah.
Okay, I believe that we could get there. These are just sort of like baby steps.
Yeah. Two comments of this is wrong again. So I agree with you completely, Tom. I think that's the engineer in both of us. That if you look at hydrogen as the energy density in hydrogen starts to rival the energy density of petroleum. The reason we use petroleum is exactly that, right? How many miles can you get on a gallon of gas, right? You want to put enough gas in your tank so you can go a decent distance. That's what's killing electric, right? Because you don't have the energy density in a battery to go a decent distance. That's why we use petroleum. Hydrogen really does rival petroleum in terms of energy density. The trick is how do you store it safely, and it's pretty easy. There are a lot of technologies that work. And then Tom hit on the key point there is how do you create hydrogen without using more energy than you save by using it? And the only obvious long-term solution is solar as a way, because solar energy is great, but solar energy, if you just capture it, has to go into a battery. And now we're back to the battery problem. So going from solar to battery isn't a long-term solution because you have all the lithium and everything else we talked about. But solar to hydrogen, and then you can store hydrogen infinitely, just like storing gasoline. And hydrogen vehicles actually are safer to drive than gasoline vehicles Because if you crack your gas tank, the gasoline goes onto the ground and starts a fire. You crack your hydrogen tank, it just goes up in the air and escapes, and you're safe. So there's a lot of advantages of a hydrogen vehicle. I wanted to end a comment on something said about the frames. I had my students in class do a wonderful mini exercise. It doesn't solve the whole problem, but it's a great example problem where we looked at a steel automobile frame, an aluminum automobile frame, and a carbon fiber automobile frame. And the simple question I asked, and we used the software that we use in our class, you can calculate the embedded energy in those three materials, and then you can also calculate the weight savings and how much gasoline over the life of the vehicle will you save in terms of emissions. And you can ask the question, is the higher embedded energy materials like aluminum and carbon fiber worth it? Do you save enough energy over the life to make it worth having them? Aluminum, the answer is pretty safely yes. Current technology is carbon fiber. You use way more energy to make the carbon fiber frame than you can ever save in gasoline over the life of the vehicle. So right now,
recyclable.
but yeah, and it's not recyclable. So aluminum right now is sort of at the peak of that curve with current technology at least. But it was a great exercise to have the students say ABC, which one and why. And you start to get, maybe this goes full circle to what we were just talking about. How do you get people to make more informed decisions? I think it's education. I think one of the cool things is we focus on complex systems thinking here. We ask you guys to become better critical thinkers and to be more interdisciplinary in thinking about the policy, the technology, the environment, all the finance, the economics. You guys are actually being trained to think about those four things simultaneously in your curricula, no matter what your majors are. And I think that's the piece, right? How do you get to a society that can make complex decisions on all four of those dimensions simultaneously? And at least for today, I'm arguing that technical dimension is one we fall down on a lot for the basic public, but I think you could argue maybe the other three too. We have a couple minutes. What are any closing thoughts from some of you about today's discussion?
I'm definitely happy that I came. I don't know what I was expecting, but I think that more conversations, I'm a fashion major, I know some textile stuff, but just hearing you guys talk about kind of the science between the other things that I use in my daily life, but I don't understand anything about. So that was really nice for me personally, and I think listeners who might not have a background knowledge in this will still be able to gain something from that, which I think is great.
George here. Someone once remarked that when you're through learning, you're through. And as a teacher, I've learned quite a bit, and I found this very educational for me, and it's also very enjoyable. And it's just great to see a lot of the young folks, the students here, very tuned in, very inquisitive, and it's been a great experience for me.
Yeah, I want to thank you guys. The thing I think we see as faculty that folks who aren't on campuses don't see is how thoughtful and articulate the current set of college students are. And I think when we see this, those of us that are the old folks in the room are a little bit more relaxed about what the world's going to be like when we retire. Because if folks like you are out there making decisions when we're in retirement homes, I'm going to be pretty comfortable. I just want to applaud you guys for being as thoughtful and engaged as you've been. And I really enjoy talking to you about this.
Thank you.
Thank you.
Thanks.
Thank you.